You set up your HCI cluster, you're all set to benchmark it. You load it up and you wait in anticipation and it doesn't perform. What now? So today we're going to explore some quick tips and best practices on benchmarking your vSAN cluster. I can pretty much be certain you will almost instantly get better results. But first and foremost, let's get this out of the door. Synthetic benchmarking is not real-life workload. I don't care if it's vSAN or traditional SAN or whatever storage. In reality, there's no such thing as a constant stream of 4K block or 8K block or whatever K block of data. Getting a million IOPS on a 4K 70 read 30 write profile in a synthetic benchmark often means nothing in the real world. So be very mindful what your goals are with regards to benchmarking and set yourself the right expectations. What you guys need to understand is this. There are many variables that affect performance, from networking to choices of drives to CPU choices, configurations and the like. Also, do stay till the end where I will share my recommendations on the tools and setups to get a very successful benchmark run. As always, clicking on that subscribe button, a like or comment will be appreciated if the content is useful for you guys. Let's kick this off. First one, make sure you have gotten all the right hardware and drivers. So what do I mean by that? vSAN has an extensive supportability matrix and it has a whole lot of stuff and combinations. We also have recommended drivers for each and every one of those hardware. Make sure you validate your setup against that matrix. This is very important. If you haven't, I would strongly suggest you start there because for every 8 or 10 issues I've dealt with in the field, it is most often hardware related. And this can and will impact your performance runs. vSAN isn't traditional SAN or RAID storage, so data placement in vSAN is a key to understanding the performance runs on vSAN. So before we look into how vSAN stores data and places data, let's look at how a traditional array would behave. So in this case, you have a VM, and when the VM sends data down, it gets broken down into multiple chunks or rehashed. Assuming this is a RAID 5 set, you would have maybe a 3+1 here, and those data set will go into different drives. So performance generally, it's also derived from the fact that you have many drives working together in unison for you. In the larger array, you will have more drives, obviously, in the hundreds. And what you tend to happen here is, again, all these drives are working together. So assuming you have a 100 terabyte drives, VMDK, that gets striped across every single drive in that array. And that's how you derive performance generally from a VM in the traditional SAN or traditional NAS array. So now let's look at vSAN's placement of data. So let's just for discussion's sake say there's a VM and they have 3 nodes in the cluster. And we would also have a policy with FTT1 and RAID 1. So assuming this VM has got a single VMDK, in vSAN what actually tends to happen is that this VMDK will then go into probably 2 nodes, and the data set will land on a single drive in that particular node. So in this instance, on a good day, I don't care how many drives that you have, but if your policy is an FTT1 RAID 1, it will be mirrored like how I've drawn in this diagram. The only time that it potentially splits into more than one, it's if the VMDKs are generally more than 255 GB. In that instance, it could potentially be looking like this, or even like that. But still, at any one point in time, we're looking at, potentially there is 18 drives here, and you are only using 4 drives. This can also be achieved if you set a policy with a stripe width of 2 or 3 or 4. In that instance, you will get this further split into multiple components. So as you can see, it doesn't really use up all the drives. In this case, you may have 18 drives, but if you have only a single VM and a single VMDK, and in this particular configuration, it probably uses up to 6 drives. So potentially to get better performance or to utilize more drives, generally what happens is that in the reality, you will have more VMs. In this case, maybe a green VM, potentially will be using this drive here and this drive here. And if this particular VM has got a stripe width policy, you may find something like this. The strategy here is to simulate as close to reality as possible. With any shared storage, often there are concurrent VMs accessing the system at the same time, so it is also crucial in order to test the limits of vSAN, we need to replicate as close by recreating not just one VM, but multiple VMs. You can also extend this further by having, maybe 2 or 4 VMDKs per VM, which is also a reflection of what you will see in real life. Doing so will ensure that the vSAN placement algorithm will have it evenly spread out across all the nodes and drives, and this will almost instantly get you better performance and an estimate of what your cluster is able to deliver. So now that you have got it all spread out, how do you then determine what number you got is the maximum of what your system can do? We do this by tweaking the outstanding I/O or the number of threads. Alternatively, we can also keep putting on more VMs, but when do you actually stop and determine what's the maximum? So to fully understand how much performance you can get out of the system, it's also important to understand the correlation between latency, outstanding I/O and IOPS, and where is the middle ground or break-even point. So in this particular diagram, I'm going to show you, you see there is OIO, which is an important metric. If you are running this, sometimes it's called outstanding I/O or OIO, or sometimes the number of threads, and obviously IOPS. Usually, in most testing tools, if you don't specify the outstanding I/O is single threaded or just one I/O at a time, but we will try to load OIO or outstanding I/O as much as possible to get the ceiling or the maximum limit that the system can take. So as you increase outstanding I/O, what tends to happen is the IOPS will generally go up as well. So you will see a graph that is similar to this. And after a while, it peters off and it kind of have slightly gradual increment of IOPS. Now let's look at latency. I'll make latency in red and measure it in milliseconds. So as you stack more and more outstanding I/O, the queues get filled up and the drives suffer and the system suffers. What you tend to see with latency, the graph will look something like that. And it will come to a point where the increment of OIO doesn't result in an exponential growth, but latency doubles or triples or quadruples. Personally, this is where I would draw the line with regards to where my maximum is pertaining to a particular system that I'm actually testing. So the sweet spot is the maximum IOPS I can attain before the latency becomes too much and the performance fat lines. As promised, here are my recommendations for tools. Of course, there are many tools or applications that you can use to test the system. Everybody's got their little favorites. So usual way, most run it, build 10 VMs or 20 VMs, install a load generator on these VMs, load up a profile to test, and then kick it off. If you ask me, this is quite tedious and manual. I personally used to be a big fan of IO meter, but as some of you may know, this tool is as old as time and has not been refreshed for like a long time. When I first started testing vSAN in the early days, this was my go-to tool. But over time, I realized I was getting inconsistent results on a similar setup with IO meter every single time. It was extremely odd. The only good thing about IO meter was the fact that it actually had a GUI. Then of course, there were other tools like FIO or vDbench. Unlike IO meter, these tools require some level of setup and doesn't have a nice fancy UI. Most of the commands were largely CLI driven. But having said that, I did get fairly consistent readings every run. So what is my recommendation? A tool called HCIBench. This tool is the best of both worlds, which uses FIO or vDbench as a load generator, and at the same time it has an automated and simple to use UI. So before you jump at me to say that this tool is built by VMware and makes vSAN look good and etc., let me explain. As I mentioned earlier, setting up many VMs, imaging it, configuring, and profiling the load gen can be quite cumbersome. What HCIBench does for you is, it takes your vCenter credentials, you then pick the load generator of your choice, be it FIO or vDbench, tell it how many VMs and VMDKs you need, and the workload profile, and how long you want it to run. All of this done through a web UI front end. It then starts deploying these workload VMs with whatever settings that you just configured. The load generator choice is yours. You can pick either FIO or vDbench. It is not a proprietary load generator from VMware. What HCIBench is really just doing is automating the process. No special sauce or secret hacks. It is not a closed loop tool. What about recommendation on the workload type? This is really a it depends kind of question. If you have an existing array, you may be able to figure out the read and write profile easily. Just look into the management console and you may be able to find some information. But whenever you're in doubt, HCIBench comes with an option called Easy Run, which consists of 3 common test profiles: 100% random read, 70-30 random read-write, and 100% sequential. This should give you a fairly good representation of what the cluster can do under different scenarios. While it runs, you can check out the metrics on the built-in Grafana front end, or you can go to vCenter under the vSAN performance tabs and look at it. I will also generally recommend running performance tests for 2 hours or more to allow the caching drives to be warmed up and filled, again simulating as close to reality as possible. Hopefully that's given you a little context as to how best to benchmark and test the vSAN environment. There are many other considerations as well, but oftentimes these are the common issues where most stumble upon. If you have any other questions relating to performance or vSAN or testing, feel free to drop me a comment and I'll try my best to answer it. Again, I want to reiterate this before I end today. Synthetic benchmarking isn't real-life performance. As always, thanks for watching. Till next time.